In this second video, or second part, we're looking at phase diagrams. This is material that one would obtain if one was taking a thermodynamics class, but it's important to discuss at this particular point. It begins by discussing what is a pure substance's phase. And it recognizes that we have solid, liquid, and gas phases. And a phase diagram is one in which the various phases are plotted as a function of the two thermodynamic properties that define the phase of a pure substance. And so if one was to plot pressure and temperature, a pure substance would be a solid in a certain area, a liquid in another area, and a vapor in the third area. There is a point called the triple point where at that pressure and at that temperature for that particular substance, all three phases are present in equilibrium. There's also a point called the critical point, and it is the point at which liquid and vapor are in equilibrium with each other, and any pressure above that or any temperature above that, there really isn't a distinction between liquid and vapor. It's just called a substance, or it's just referred to as a gaseous material. And so when you have those particular areas, based on the temperature and based on the pressure, you can identify what phase the substance is in. And then as you go from one phase to another phase by holding pressure constant and increasing the temperature, you can see that occurs, and that point at which it goes through the phase boundary is referred to as the melting point. And again, that melting point consists of, or is at any given pressure, it's at a higher and higher temperature, let's say. And so you can follow that particular behavior. Again, this line right there separating the solid and the liquid phase is the melting line. It's also, if you're going the other way, it's the solidification line. As it goes from a solid to a liquid, it can also go from a liquid back to a solid. If one was to start at a given pressure and temperature such that one is in the solid phase, one can see that even if temperature stays the same, the pressure could be changed, and you could actually go through that liquid line, that melting line, by decreasing the pressure at a constant temperature. Over here on this side, where we're in between the liquid and the vapor region, we can make similar discussion points at a given pressure. We can see that by increasing the temperature, we can go from a liquid to a vapor. Likewise, if we're at a given pressure at a constant temperature, we could lower the pressure and actually go from the liquid to the vapor. So this line right here, as you go through it, would be referred to as the boiling or the evaporation line. If you were going the other way, it would be considered the condensation line. And again, the critical point is that one point there, and the effect of pressures and temperatures are shown. Down in this particular region, below the triple point, we see that we can start at a given pressure. We can start as a solid at a given temperature, and by increasing the temperature, we could actually see that we could move from the solid directly to the vapor condition. And that process along that line is called the sublimation process. And so solid turns directly into vapor without going through the liquid state. A very common substance that you may be familiar with is solid carbon dioxide, or dry ice. It is at atmospheric pressure. It is at a low enough temperature such that it's in the solid phase. But if the temperature is increased, one can see it actually will go directly to the vapor phase without observing any liquid CO2. Again, this point that's marked T, is referred to as the triple point. Now, when one has a substance, typically a pure substance, is defined by a melting point and a boiling point. And whenever you see it listed as the normal melting or boiling point, it corresponds to at 1 atmosphere of pressure. And so if I had a chunk of, let's say, solid gold, and I have that chunk of solid gold at 1 atmosphere of pressure, I could tell you what temperature I would start to see it melt. And that would be this normal melting point. If I allowed the liquid to get warmer and warmer, eventually the liquid gold would start to boil. And I would be at the normal boiling point. And one can see that depending on the pressure, those melting and boiling points can change. And so, since we're going to be discussing water, because we're interested in water and ethanol mixtures, this is the phase diagram for a pure substance, water. And as you can see, the interface between the solid, the liquid, and the vapor. The unique thing about that, even though there is a triple point and a critical point, if one was to compare that to a similar type of phase diagrams that we've talked about before, what one sees is a strange effect in that this line here, it leans forward, whereas for water, it is the only substance where that particular line emanating out of the triple point actually moves or leans toward the backside. And so that is one of the main differences between water and any other type of substance. And what this tells us is that when water goes from the liquid to the solid phase, its density decreases. It occupies more volume. And we know that that's the case. Whenever water freezes, we know that the ice cube actually gets bigger. That's what causes pipes to freeze and other things like that. So that is a direct effect of that particular type of curve. Had it been any other liquid where the line goes in the other direction, as something went to the solid phase, it would actually get smaller. It would get more dense. But we're glad that we've got water that can do that, so that we have bursted pipes during the wintertime. And so this is showing you again some more information about water. We know that the normal boiling point for water is at 100 C at 1 atmosphere, and so that's this point here. It gives some information about the melting point and the triple point, as well as this critical point for water. And again, going through the different phase. Now here is a phase diagram for carbon dioxide. Carbon dioxide is typically, we think of carbon dioxide as a vapor, but it can also be a liquid at certain pressures and temperatures. And at low enough temperatures, it could also be a solid, which we call dry ice. And so that this particular part 2 is just discussing the various phase diagrams for pure substances, so that we understand how water goes between the three phases, and how ethanol will go through the three phases. And what we're now interested in is putting two pure substances together and seeing what the behavior is like when we have a mixture of two pure substances. And the two pure substances that were of interest is ethanol or alcohol, and in a solution with liquid water.